Hello, everyone. Thanks for the warm welcome. So as mentioned, we'll be talking about asynchronous Python. We'll try to show you that concurrency can be without the headaches. And let's kick off. But we would like to first introduce ourselves. I'm Mateusz Zaremba. I'm application architect at Ørsted. Ørsted is a company that builds and operates wind farms. And with me is Krzysiek. Krzysiek.
Hey everyone, I'm Krzysiek and I work for Amazon Web Services. I'm a DevOps engineer. AWS makes the clouds, so I guess the wind, the clouds, the windmills, it all connects. And we worked quite a lot together with Mateusz. We wrote Python code for years, but the story of this talk is that we never kind of were convinced 100% that, hey, this is actually the place where we use async, where we actually learn it and put it in production code. We were never 100% sure. So this is kind of the story of this talk. We made it because we wanted to really learn it. We applied for different conferences with it. We got accepted to plenty. So let it also be an empowerment story for you that if you ever consider applying for conferences like EuroPython, you are good enough. You don't have to be like 100% expert, just try. As I mentioned, this is going to be a practical guide, and this presentation was born as our own learning story. So what's the best way to learn new things in IT? You start a new side project. This is kind of the side project. So let me kick off by saying that async is hard. And our aim here is to make it easier for the beginners to understand what to watch out for, when to use it, when not to use it. And the common pitfalls you might be falling into and losing all the benefits of using async Python. Because you either do it 100%, you go all in, or you don't do it at all. Because it's very easy to shoot yourself in the foot and kind of lose all the benefits of the async code that you're writing. And sometimes it's not even your fault 100%, so you need to really understand what you're doing. And before we talk about why async, let's talk about what is async actually.
Yeah. So what is async? So let's first talk about this indeed. And even before we talk about what is async, we need to talk about what is synchronous, or I'll try to use word blocking, just so it's not mistaken with async, sync, those are similar words. So let's start with the blocking, so the normal, let's say, usual way you use Python. And let's take this sample code. Yeah, it's very simple. We just import something, in this case time. We have a definition of a function. Inside the function, you can see first, we just print something, hello from the synchronous function. Then we simulate that we actually do something. In this case, it's just sleep, but that's where you would, for example, download the file. And then after this, we print that we're finished with whatever we've been doing. Again, here, we just say we finished downloading the file. And then we actually execute this function. So let's take a look at how it would work. So yeah, it's pretty as expected. So we import, we see the function execution, we go into the code. We first see, okay, the code is executed line by line, so we print that hello. Then we wait for 2 seconds where we would do something, and then we're done. We see print that finished with downloading file. And here is actually something where we could do better, because we are waiting for 2 seconds. That's not efficient. We could do something when we are waiting. So this is exactly what asynchronous Python, what asynchronous way of writing Python is try to leverage. So we can do something when we're waiting for something else.
Something that we don't control.
Something that we don't control, indeed.
So, by the way, if you get upset by oversimplification of the control flow here, this is not our goal to go into the internals in this presentation. We want to go into async and how to use it.
Yeah, it is simplified. So asynchronous Python. We now see the purpose. We could be something more efficient when we're waiting, and that's basically the asynchronous Python where it could help us. So tasks can yield control. And now the word task, we didn't explain it, but think of it for now as something that we have to do. And what yielding control means? Well, I don't need to stay. The task doesn't have to block me. The task can yield control to something else. Therefore, execution can be non-blocking. So we're not waiting till the task completes. While we're waiting, we can go and do something else. So it's non-blocking. Therefore, we do not necessarily stop and wait till each line is completed. And therefore, we can be more efficient. So again, think of this time sleep. We can do something when we're waiting. But there is a trade-off. Control flow is more difficult. So figuring out what is happening and when and why when you're debugging when something is going not as expected, it's not so easy. It's not so obvious. It doesn't have to be in the same order as you expect it to be. So maybe some code now. Let's see.
That would be lovely, but unfortunately, not yet.
That was a smooth mic change.
It was dangerous with the feedback. Sorry, audio guys. Let's talk about concurrency and parallelism, because we really need to understand what's the difference here. And again, let's go quickly through this before we jump into the code examples. Let's say we have two tasks, task 1 and task 2. Those tasks can be depending on each other, or they cannot be depending on each other. And if you think about parallelism, you could execute both of those tasks, for instance, with two CPUs, with multi-threading, multi-processing. Those tasks need to execute. They don't have to interact too much. So we can just use even two machines. We can deploy it in the cloud and have like completely separate workloads. We can solve it with architecture, not with code. And when you think about concurrency, we can have one worker and two tasks that Mateusz mentioned can yield control, which means if task 1 notices that it's waiting for some external process, some external event to complete, database query that is taking forever, then we can switch the context of the execution to task 1, work on it a bit, then when it gets blocked, get back to task 1, right? And we keep going until both tasks are finished, and we just need one worker. And this is where async shines. This is the primary kind of introduction. We will be talking about concurrency on a single thread. And you might be thinking, yeah, but Python has multi-threading, right? And there was actually a good talk yesterday about it, when to use multi-threading, when to use async, when to use regular blocking code. This presentation doesn't aim to jump that deep. We want to focus on single-threaded concurrent executions, where async actually shines and where it's actually the most common use case. So let's get back to async. And let's get back to the problem we are solving, because really when you are programming, you want to solve a problem. You don't want to use a fancy technology for the sake of using a fancy technology. And let's differentiate between IO-bound tasks and CPU-bound tasks. When we think about IO-bound tasks, we think about something that is limiting us from the outside. So it can be a network query. It can be downloading a file, as Mateusz mentioned. It can be a long-running API query. It can be a database query that takes just forever to complete. This is perfect for async, because we are waiting for something external. Our code can just switch context to something else until this external event completes. When we think about CPU-bound tasks, so kind of a primary line of thinking when you think if this is an async use case is to think this way. And if you have to run some heavy computations, if you need to run some rendering or whatever else that just needs a lot of computing power that not necessarily can be just handed over back to our codes, the control of the operation, it's definitely not the case, because you can solve it in much more efficient ways with multi-processing, multi-threading, perhaps even, as I mentioned, some architectural decision to just split the workloads and gather the results otherwise. So let's finally get to some code and talk about the visual comparison. So let's say I have this code. I'm very sorry if it's too small at the back. I will try to explain whatever is happening here. So we have a small function definition where we are just simulating, let's say, a database query by sleeping 1 second, right? It's a regular code. Let's say I wrote it, and I run this task 3 times with 3 different, let's say, delays, or I could just run it 3 times. This task will not be very efficient because we'll be sleeping as many times as I call it. And I have a clever colleague that already is used to async code. And he came to me and gave me this code. So I say, yeah, why not? We can try it. But looking at the code, I quickly noticed that, it doesn't look like the Python I'm used to, right? It has this keyword async before the function definition. It has some await keyword that I also haven't seen before. Then there is some weird way to schedule those jobs with some gather and some run keyword. I don't know why cannot I just call my Python method, right? So before we really talk about use cases and how to apply async and where are the pitfalls, we still need to think about the syntax itself. So let's just quickly explain the syntax.
Yeah, and we'll need 3 elements. So the first element, something that we've seen on the previous slide, the async def. So we're used to the definition of function that starts with with the word def. But now we have something special in front of it and actually changes quite a lot. So async def defines a coroutine. Now, what is a coroutine? Coroutine is a function that can yield control with something that we can say, okay, it will be paused at some point. It will wait for something at some point in the time. Therefore, we may do something in the meantime, but then how do we highlight where do we wait? So we need somehow to tell Python, because we are still talking about single thread, that this is a moment that we can look at something else. So await is a way of marking, I am expecting that the thing on the right side will take some time. So I don't need to do anything, like this function can stop until the thing on the right side of the await is completed. And by the way, it's called, the thing on the right side is awaitable. So if you look at the docs, if you see awaitable, that's the thing that's on the right of the await. There's a little bit more nuisance to this, but for now, let's just go with this. And there's a third part that you may, but you don't have to. And usually you don't look directly. There is the event loop. And the event loop, you could call it the heart of the async execution. So what event loop does is that when it sees that your coroutine, again, not function, a coroutine, is waiting for something, so it hit this await, and we're waiting for the thing on the right side of the await to complete, event loop is something that says, okay, I'll now go and do some other things that I could do in the meantime, and I'll later come back and see if this awaitable has completed. So we call it the heart here, but we could also think about it as the brain. And the reason why I'm saying a brain of the asynchronous execution, because I can also be kind of an event loop, and we'll cook the async pasta, and my brain, I am single-threaded. I actually am single-threaded, but I still can cook. So, and then I will be the event loop in this case. So we'll be cooking asynchronous pasta. It will be Polish asynchronous pasta. You wanted to add something?
Just a quick question. Are there Italians in the audience? I'm very sorry, guys. What you're about to witness.
We'll be doing a pasta with strawberries, okay?
The Polish way.
Yeah, so we'll need 3 things. It's strawberries, pasta, your favorite one. Could be shells, could be ribbons, and then we'll need light cream. So it's a very basic one. And we'll start. So how do we do the pasta? Well, I'll first need to go and do groceries, and I'll just do it synchronously. I just go there and focus, do it, come back. I will not do anything in the meantime, so I'll just do it. But then I hit the first point where I actually need to wait for something. So I need to boil water, and it's asynchronous because when I put the water on the stovetop, I put the pot on the stovetop, and I turn it on, I'm not looking at it until it completes. I'm not making any faster when I'm looking at the water trying to get to the 100 degrees. So yeah, I can do something in the meantime. So I'll just await boiling water. So I'm thinking, again, one thing at a time. I look at the water. It's not yet boiling. I'll go do something else. So I can blend the strawberries. Yeah, again, I put them in the blender, and I just await till it completes. I go check again on the water, whether it's boiling or not. I'm not constantly thinking and looking at the strawberries, because the water may be already boiling. Maybe it's finished. And then I can actually cook the pasta. So again, at some point I notice the water is boiling, so I can just throw in the pasta and wait until it completes. Again, I'm not making any faster if I keep on looking at it. I can think about other things. But when all of those are completed, I can just add the strawberries. And it's, again, we're going back to the synchronous one. I'll just combine, do it. I'll not be doing anything in the meantime, so there's no waiting. I just do it. And then I just enjoy the meal, and it's yummy. Yeah, so in this case, I was the event loop, and I was still thinking about one thing at a time, but I managed to complete things in the meantime, which is exactly this single-threaded concurrency. And now we can go into more of a more defined or like more coding-related showcase of what is the event loop.
Yeah, let's get back to it, and the Italians can, again, look at the slides. I'm very sorry, again. So, when we thought about Mateusz cooking as an event loop, what really happened is we were scheduling certain tasks on the event loop, being his brain, and we had 3 tasks in this case: boiling water, preparing the pasta sauce, whatever it might be, and then, yeah, cooking the pasta itself. So when we think about it, the event loop was really starting to run those tasks. So one by one, it was picking the tasks. When it detected that the tasks become blocked, so they are waiting for something external, so we hit the await keyword. They were yielding the control, meaning they were put on a waiting list until this external event completes, like the water gets cooked, or a database query actually executes and returns something. So we could switch to doing something else, right? Like a second task. When this task gets blocked, again, it's put on the wait list. We are checking whether those tasks didn't complete in the meantime. If not, then we are just taking the third one, starting running it. Maybe it got completed in the meantime. So we actually complete these tasks. And at the end of the day, our goal is to execute those tasks one by one. When they hit something external that they are awaiting, they will be put on a waiting list. And then we'll get back to them when they are ready to go. So you already see the performance gain here, but again, the performance gain is if we do it properly. So this is the event loop. And by the way, are there some Golang developers in the audience? You must be having fun here. So now, finally, it's the coding time.
Yeah. So let's look at the code examples. And we start with a simple example. And let's go quickly through it. We'll be coming back to this example, so please do pay attention to what this code does. It's actually just printing, so very similar to what we've seen before, that it starts to fetch, then it sleeps for a given delay. So we simulate, again, doing something when we sleep. And then we print that we're done. And that's basically what this function does. But do see that we have the async keyword in front of the definition, so it's not a function, it will be a coroutine, and it has await. So here we are not normal sleeping, we are doing the await version, the async IO version of sleeping.
And remember, this will be important in a few slides.
Yeah. So we get the definition of our coroutine, and then we'll just run it. Again, running is slightly different than that we used to do it in a normal way. So again, we have some function that will await, and then in the main normal blocking way, we just call it from asyncio.run. We can be doing it in a couple of different ways, but for now, let's just watch out for a danger that's here related to the way we run the coroutines. So something I mentioned, but I still want to highlight, if you have a coroutine, so you define it with async def, you cannot run it like this. This doesn't work. It does something else. It just returns you the coroutine object. So basically, you cannot do this. This will not work. You will be sad because you probably even may not notice it because debugging asynchronous Python, as we said, it's not so clear. So just please do remember that this is not the way to run the coroutines. It will not work. So the upper way, my coroutine and the brackets, not the way to do it. The way you should do it is either await it, do async IO run, or a couple more ways. We'll show some of them. But basically, going back to the simple example, now you can see that we actually do the await and then async IO run. So that's why we run it. And now, when we run it, you might say, why are you doing it in an asynchronous way? Are you getting any benefit? And the answer is, in this case, no. You might as well just do it normally. But we'll build on this example. So that's why it's important. So that you remember that we are trying to fetch the data, we'll mock it, and we have some delays.
Sorry, to be more inclusive, because some people might not see the exact code. We are just running one operation in this coroutine, and we are just calling it once, and this is the reason why it doesn't give us anything in this case. It could just as well be blocking because we cannot do anything else, right?
Yeah. So we're just awaiting the fetch data to complete just once, and that's it. But now it's time for gather, and the gather is a way to run your tasks. Now, coroutine tasks, there is slight difference. So the gather converts our coroutines into tasks, but basically we're running it 3 times, the fetch data, with slightly different delays. So you can see that the first fetch data that we put there will wait about 1 second, the second one will wait 4 seconds, and the third one will wait 1 second. And they have different names. So the first one is API 1, 2, and 3. And now this is a moment where we actually get some benefit. So the moment we try to run something in the same time, we'll be getting some benefit. So Yeah, if we run it, what are we expecting to see? Well, the beginning is pretty clear. We just start to fetch API 1, we see start to fetch API 2, we see start to fetch API 3, as expected. But then we see that we finished fetching API 1. Again, nothing spectacular here, it's just as expected. And then finished fetching API 3. So we see the change of the order. So first, API 3 has completed because the delay of the API 3 was 1 second. So it was done faster. When we were waiting for API 2 to complete, the event loop picked up that, yeah, API 3 has done. It's done. So we can go finish whatever API 3 has to do and go back to API 2. And then you see that API 2 has completed. So we see the change of order. And then there's also benefit to this because you can see total time 4 seconds. So around what's the longest time it took to complete. And Spotify has opened.
Very sorry.
OK. Total time 4 seconds. So the time that maximum delay was the longest operation took. Approximately, it was slightly longer than this, but around 4 seconds. So now we see the benefit. We just took not the sum, so not 6 seconds, but 4 seconds, which is nice. And we can build on top of this. We can add actually more things to what we want to do.
Yeah. So coming back to this example of gather. Let's make a new coroutine, right? Let's say I'm a new developer. Mateusz shared this fancy async code with me, and I want to add my coroutine there. I want to execute something else in the meantime. So I wrote this quick coroutine. And some of you might be already smiling, but we'll come back to this. We put it in the gather function to schedule it on our event loop, and we run it, right? Simple enough. So looking at the results, I was happy. I see that it's run. It looks like all coroutines finished, but looking at the order of the coroutines that were run, do you see something weird here? Any coroutine that was after my new fancy my operation coroutine didn't even start before my new fancy coroutine executed. And the entire execution time was 10 seconds, which is actually more than the 6 seconds in my new coroutine, which should be the longest running task. So the entire gather should return in about 6 seconds, right? What happened here? Do you see it? Nice, OK. So exactly. I used time.sleep instead of the asynchronous implementation of the sleep function. And yeah, I didn't notice that. So what that means really is that whenever you are relying on some external code, let it be your own code or some external modules that you want to use in your code, you still need to think, hey, can I use it in asynchronous context? And you might lose all the benefit of using your fancy asynchronous code if you just miss something like this. So you might be thinking, OK, this is one example, but there's more. There is much more that can happen. And I don't even want to start talking about all those problems. But I want to give you a tip how to fix it or how to make it harder to shoot yourself in the foot with this. So Async.io comes with, I saw some people taking photos. We can share it with you if you like the memes. I appreciate it. Anyway, coming back to it. Async.io has a debug mode, which greatly extends what you can do. You can enable it in 3 different ways. Again, sorry for the small letters. You can just add it on the event loop level, but you shouldn't probably dive deep to get into the event loop objects. But you can just have a flag in your async.io.run or gather. And you can also enable it with an environment variable. And what you will get out of it is the problems that were on the meme will get much easier to pinpoint and debug, because you will finally see that you missed an await keyword, for instance. Or you have a long-running blocking operation that blocked your event loop. All of that will be visible in the logs. You will get proper tracebacks and all of this. So if you want to start working with async, and this is your first time, even if it's not the first time, when you're developing the code, make sure to run it with the debug mode to see what is really happening, how the event loop processes those tasks, and if there are no warnings, because it is very easy to miss one simple thing and then lose all of this optimization.
So yeah, so remember the sad frog, right? Debug mode would help.
and test your code. We all do that, as Henrik said. Okay, common use cases. So where actually async shines, because we focused on a bit what to watch out for, what are actually the great use cases?
So there are some pretty clear use cases. So that when we mention it, when you're waiting for something external, that's probably when you can use the async. So you want to read, for example, read files. And by the way, we just showed the example of libraries that could do that, but it doesn't mean that those are the only ones. Maybe you want to download files from the web. So again, example that we mentioned a couple of times, you're waiting for the download to complete. Your Python is not doing anything, it's just waiting. So we could do something in the meantime. Maybe you want to run queries. Again, mention this example. So again, waiting. This is the common pattern that you see, that when you're waiting for something, your Python is not busy. You could do something. So for example, SQL Alchemy with async session. You want to run a web server? Fast API has built-in support for this. But always think about your dependencies. Because if you, again, do this mixing with like, there's some blocking code, you may lose the benefits, and yet you still have the code that that looks like it's asynchronous, but it's just stuck somewhere. But what if you have another use case? So of course, we didn't list all of them. Do you want? What do you have another use case? Well, you probably should work backwards. So think about the problem. Is it something that fundamentally, where you need to wait for something, that you're not busy, that your Python, your process is not busy? Because if you just throw in async at the slow code, it probably won't make it faster. It just, unfortunately, doesn't work like this. So that's not the solution. You really need to think about the problem and understand whether you're waiting. But at least some of the bits, for some of the bits, there must be a simpler way. So hopefully there is a way to do something easier, simpler. Is there?
Glad you asked. Totally unexpected. So let's quickly talk about Asyncer. And we have Sebastian Ramirez on this conference. He's the author of this bundle of functions. So he's probably the great guy to talk to if you want to learn more about it. But what Asyncer gives you is a set of opinionated functions that you can also use in a decorator pattern like this to make, first of all, your code a bit more readable, and mixing of the async code with the blocking code a little bit easier, especially if you think in the context of working with different developers. You want your code to be easy to use. So if you write an async coroutine, you want someone to be able to use it in the context of their code, maybe without changing it too much, right? So with Asyncer, you can do, for instance, an asyncify, and we are just skimming the surface here. There is more, where you have a blocking code, but you want it to make it executable in the asynchronous context. And the other way around, you can runify code with a runify decorator, and it will make this asynchronous fetch data method callable from the blocking context, just like a regular Python function or a method. And you might be thinking, is this magic? Does it like convert my code under the hood? It's nothing like that. It's actually a very clever use of any I/O under the hood, and just a set of wrapper functions that make it much more reusable or easier to read, easier to debug, because it also leverages the typing and auto-completion that you wouldn't have with regular async I/O code. So if you want to make your life easier and you want to mix the code, this is how you would run it, for instance, as I mentioned, in the different contexts, switching context between async and blocking. This is a great way to start, and you might be, again, noticing this time.sleep. And I highly recommend you read the Asyncer documentation. It's amazing, and it dives deep into how it would handle this kind of situations. For instance, we won't go too far here, but there is a very clever way of doing this with just extra threads that kind of make your code work asynchronously, but with some trickery there.
So Krzysztof, I have a question. Does it mean that I don't need to think about the event loop and waiting and so on? I just put the asyncer and that's it?
No, you still need to think about it. You should know what's happening under the hood of your code, especially with async, because again, you might lose your benefits, your performance gains very quickly. So this is just a way to make your developer experience and developer experiences of your peers much better. And make your code slightly more testable and easier to read. Again, Python is about readability in the long run, so highly recommend to try it out. Again, yeah, let's wrap up because we might be running out of time and we maybe, no, it's good. We were quicker than expected. Then we have some time for questions. This will be interesting. Amazing. Okay, thanks. Let's start by wrapping up and saying when not to use async, because I think it's important, again, to rephrase this. Async is not a silver bullet to solve your performance problems. When you have simple and like short-running scripts, there is probably no reason to use it. When you have CPU-bound applications, again, CPU versus I/O-bound operations, when you have CPU-bound applications such as heavy computation, GPU rendering, stuff like this, there's probably no use case there. But again, you should always work backwards from your problem and then only think about the technologies to use. No silver bullets. When the libraries you depend on are not async compatible, you lose all the benefits. Remember the time.sleep that I called and blocked the event loop completely? You can easily do it with any other module that is not compatible. And again, this might sound a little bit like silly for some of you when your team is not familiar with async patterns. Because if you are a great developer, good for you, love it, and you know all the async patterns and all the magic under the hood, and you can actually leverage this, good for you. But if your team cannot do that, you read the code much more often than you write it, right? Especially in the enterprise context. And if you get a minor performance benefit out of overcomplicating your code and making it hard to maintain for your peers, and then there is a bus factor, you get hit by the bus. Yeah, think about your colleagues. And yeah, think about maintainability in the long run. The negative part aside, let's talk about the key takeaways.
Yeah, so async Python, well, it shines for the I/O-bound tasks. Like we repeated a couple of times. I/O-bound, you're waiting for something external. Python is not busy with anything. Yeah, you are getting something there. Then please think about this event loop as the single-threaded single-threaded loop that still allows for concurrency. So again, the way I was cooking the pasta, this is, even though I'm single-threaded and the event loop is single-threaded, you can still do things in the meantime. And then watch out, we're mixing blocking, so the synchronous blocking code with async code, so you don't lose the benefit. And then there's the keyest takeaway. Async Python is amazing. It really does a lot of, it helps you a lot and really can make you more efficient, but it can get very complex if you let it. So that's the keyest takeaway. We have a couple of useful resources. You may want to take a look. If you scan the QR code, there's more. You can see those links. And that's it. Thank you very much. That was Asynchronous Python without headaches. I am Mateusz Zaremba, and with me is Krzysztof Wilczyński.
Thank you very much.
And
that was a great talk. I can see we've got a question already, so if you'd like to.
So while still awaiting for the question to load, I'm going to thank you for spreading the love of strawberry pasta and spreading our culture. And the question now, any advice on testing this thing, and especially when you mix sync, like blocking and async?
Yeah, so as I mentioned at the beginning, this is our learning journey, so I won't pretend I'm an expert in testing async code. But of course, there are ways to do it. I highly recommend to get back to the resource list here. There's plenty of resources online. And of course, while testing, you could also leverage the debug mode in Async.io, which is probably not the best way, but this is where I would start. So yeah. Again, we would greatly appreciate your feedback. We missed saying this because we want to make this session better and hopefully make our presenter skills better as well. So thanks, appreciate it.
Hi, thank you for this great talk. I have a question. Like, I'm a bit familiar with async in Python and also familiar with async in JavaScript/TypeScript. Yeah. And there is this kind of like a handy way of handling the promises that are returned from the asynchronous functions. Is there anything similar like that in Python? Thank you.
Mateusz is nodding, so I'll let him.
Yeah, there are promises in Python as well. You can see them. We didn't include them in the presentation for the sake of time to make sure that we can cover all the topics that can help you start. But I highly recommend taking a look at the documentation. If you want to get into promises, then in Python you actually can. So it is underneath, but we just didn't see this because you have this in their futures. You can see this as a way here, what we showed, way to start. But I highly encourage to take a look what is deeper because it's much, much deeper. We just didn't cover a lot. We just scraped the surface with the hope that now you can read the documentation and see what's underneath.
Hi, just one question about the async way. I have 100 calling to database at the same time, and all of them are independent. So do you prefer in Lambda, AWS? So do you prefer use this in Lambda or on EC2 Fargate?
So I think, Krzysztof, this is a question to you.
Okay, I think this question has so much context that we should talk about it in the corridor. I'm happy to think about it because it's also an architectural question that you're asking. It's not only about the code, right? What runtime to choose for this kind of operation.
Talking about the performance, you said sometimes the async make a performance, but do you think that it's worth it to use it on Lambda, or because Lambda has a limit of memory and input-output? So for the sake of this reason,
I mean, of course you could, but I guess we would need to talk about your use case specifically to understand if it really makes sense. But yeah, anything is possible. But with AWS, as I mentioned, sometimes you can solve those problems by architectural decisions, not necessarily by changing the code.
What you mean, yeah.
So running multiple lambdas in parallel could also be the case. But we would need to talk about the specific setup of your code base, of your team, to see if it makes sense.
Yeah, sure. Thank you.
But happy to catch up, really.
I think that answer was the famous "it depends."
Of course, with most answers, I'm very sorry for this. It's very hard to give AWS recommendations in a short question in 2 minutes.
Okay, next question.
So, hi, this is a bit of a shameless plug, but there's an NEIO sprint coming in the weekend. NEIO is a library that gives a different API on top of Async.io.
Yep.
Provides, for example, structured concurrency and PyTest support, asynchronous file support, path support, and plenty of others used by Starlight Fast API, MCP, what have you. So if you have any questions on async Python, then you are welcome to come ask these questions at the NEIO sprint.
Amazing. Thanks for this. And by the way, this is the component that is the magic under the hood of Asyncer. So really, this is amazing, and read about it. Highly recommend it. Thanks for the shameless plug. It was very useful.
So I have a question, sort of going back to one of the earlier slides where you gathered a bunch of tasks together, and I noticed those tasks didn't return any values, but I suspect in my use case I would probably want to return something from those asynchronous tasks. How would I get those return values from a gather call?
You want to handle it, or?
Well, yeah, you can get to the results. We don't have a good example here in the code, so. Sorry, I'll not show it. But good feedback, yes. And again, we're slightly going into the topic of the futures. But the short answer is there is a way, but I just don't have an example. It would be very much easier to show it with the code.
Okay, thank you.
And I have a short question to all of you. This is our first EuroPython, and we are really happy to be here. Can we take a selfie with you? I see plenty of people with red badges. So. We would love it, so please, the red badges, if you don't want to be on the selfie, just lean back or lean behind someone. Is it fine?
If anybody objects, stick up your hand now.
Okay, cool.
Okay,
then we would love it. Thanks so much. Thank you. This was shameless.
Okay.